this assignment, we're going to start talking about straight lines, equations that generate lines, and the graphs that those lines produce. So starting with the slope, we have lines that can be going horizontal. If we look at them left to right, they can be going uphill or downhill. And the way we denote that in the equation is what we call the slope. If we have a horizontal line, it's like a road going through the desert. There's no hill. So we call that slope 0. If we're going uphill, we would say we have a slope that's a positive slope. And if we're going downhill, we would say that's a negative slope. And we can find the slope given a couple of points. So if we're given 2 points, as we are in this example, we have the points 6, 2 and 7, 5. Now remember that the first number is an x and the second number is a y. So in the 6, 2, that means x is 6 and y is 2. In the second point, x is 7 and y is 5. The equation for finding the slope is this. We call the slope m. And we denote it by y2 minus y1 divided by x2 minus x1. So that's the y from the second point minus the y value in the first point, the x value in the second point minus the x value in the first point. So looking at those 2 points then, we would say y2 is a 5 minus the y in the first point is a 2 divided by x in the second point is a 7 minus the x in the first point is a 6. 5 minus 2 is 3. 7 minus 6 is 1. So the slope is 3. And that would be our answer for that first problem. Okay. Let's move on then and look at number 4. Let's copy this one. Now in this case, they've actually given us 2 points, but I chose this one because it's not obvious that we have 2 points up there. Obviously 4, 8, that looks like a point. But the x-intercept is 3. Well, remember that the x-intercept is where we cross the x-axis. So the y value is 0. So we could write that x-intercept is 3 as a point, and that point would be 3, 0. X is 3, y is 0. We're on the x-axis. Okay. Now, it asks us to write the equation for the line in point-slope form and slope-intercept form. So we need to learn these 2 forms. The point-slope form is denoted by this. Y minus y1 is equal to m times x minus x1. Now let's talk about that. The y and the x without the subscript are just the variables y and x, so they're going to stay y and x in the equation. But y1 and x1 are particular values of y1 and x1. In this case, we could use the 4 for x1 and the 8 for y1. And m, of course, is the slope. Well, remember from the last problem, we found the slope by 2 points. We now have 2 points, 4, 8 and 3, 0. So let's look at the equation for finding m using the same one as before. M is y2 minus y1 over x2 minus x1. y2 is 0, y1 is 8, x2 is 3, x1 is 4, so that's minus 8 over a minus 1, but that's just 8. 2 minuses would cancel out. So, writing this equation now, y minus, well, we chose 8 as y1 equals, now we know m is 8, times x minus, and 4 is x1. So there is the answer. So that would be point slope form. Notice somebody later can look at that and say, oh, the slope is 8, and oh, there's a point here, x is 4 when y is 8. So that's why it's called the point slope form. Notice I did not distribute the 8. Be very careful. You've been taught to distribute, but in this form, we leave it like that. Now we want to move on to the slope-intercept form. Well, the slope-intercept form is probably more familiar to you. It's sometimes called the y equals mx plus b, where m is the slope again. We know that's 8. And b is the y-intercept. Well, I can get there by taking the point slope form that we just constructed and actually solving for y. So first of all, let's distribute now the 8. So we would have y minus 8 is equal to 8x minus 32. Remember, it's 8 times the 4. Now we want to move the negative 8. Well, to move a negative 8, we want to add 8. So y is equal to 8x minus 32 plus 8. The negative 32 plus 8 is minus 24. Now we have it in the form y equals mx plus b. So here are the two forms that it was asking for. All right. Let's take a look at what this would look like if we were to graph it. First of all, from that last problem, we now know that the equation they gave us is in the form of slope-intercept, y equals mx plus b. That means that the slope is 3 and the y-intercept is 6. So we already have starting points here. So the first question is, what's the slope? The slope is 3. What's the y-intercept? Well, the y-intercept is the 6. So what's this going to look like when we graph it? Well, let's blow that up so we can see it bigger. We're going to use the line drawing tool, and we're going to start with the y-intercept because we know that's a point on the line. So that's 6 and it's on the y-axis. Our slope is 3. Well, that's like saying 3 over 1. The change in y, which is on top, is 3. The change in x is 1. Well, that would mean we go up 3 and right 1. And that would be our line. And we are done. All right. Let's take a look at another example. What about this one? Y equals 7. When students see this, they're often confused because it looks too simple. Well, there are a couple of ways to look at it. That's still in the y equals mx plus b form, but the 7 is b, y-intercept. What happened to the mx? Well, if m is 0, 0 times x is 0, and that term falls out. So what this is a line with no slope, with a slope of 0. Sorry, there is a slope. The slope is 0, which means it's horizontal. Remember the line in the road in the desert. So in this case, we want a horizontal line, but we want the y-intercept to be b. Well, to look at that and get that graph, we would use the line tool. We're going to go up to 7. Just pick any other point at 7. Construct your line. All right, and there's your answer. Okay. Let's look at another way that this might be presented to us. In this case, what they've done is given us 2 points, but one of the values is missing, so all they did was plug in a y, but they did tell us that the slope is -2. Well, can we figure out what that value of y is? How about if we use the slope equation y2 minus y1 over x2 minus x1? Let's try that one. So if I start with y2 minus y1 divided by x2 minus x1. But I know now that it equals -2, don't I? Well, let's fill it in. y2 is 6. y1 is that one we don't know. That's just y. x2 is a -2. And x1 is a 4. But it equals -2. Well, let's see. That's 6 minus y on the top. But -2, -4 is -6. Now, I can move the denominator -6 by multiplying both sides by -6. Remember, you always do the opposite of what it is. If it looks like it's dividing, then you multiply. So I want a -6 multiplied by -2. That's going to give me 6 minus y is equal to -6 times -2 is a positive 12. Now I've got another 6, this one. I need to move it. This one being added to the -y. So to move it, I need to subtract it. So I'm going to subtract the 6 from both sides. Now I'll get -y is equal to, well, 12 minus 6 is 6. That's -y. What's positive y? Positive y is -6. Okay? So that's the value of y, -6. Do another problem here. These 2 lines are parallel. Parallel means, like railroad tracks, they're going in the same direction. So, in our case, if 2 lines are parallel, then they'll have the same slope. And that's kind of how you see it. They're sloped the same. So, since I know that the blue line has the equation y equals 2x, notice the b is missing because it goes through the origin 0. So the y-intercept is 0. But the slope is 2, because remember that's the m in front of x. So the slope is 2. So the red line also has a slope of 2. So we want to do this in point-slope form and slope-intercept form. Well, let's start with point-slope form. That means I need the slope, well that's 2, and I need a point, and they've given me a point 2, 1. So that would mean then that my point-slope form, which if you remember is y minus y1 is equal to m times x minus x1. So in this case, it's y minus the y1 they gave us is 1. The slope is 2 times x minus, and the x they gave us is a 2. So there we have point-slope form. Now what about slope-intercept? Well, to get the slope-intercept, I want to solve for y. So y minus 1 is equal to 2x minus 4, multiply through by the 2. Now I need to move the -1, so I'm going to add 1 to both sides. So y equals 2x minus 3. And that would be then the slope-intercept form. There's the point slope form. Okay? So that would be both forms given the information they gave us. Let's take a look at a different form. What if the lines are perpendicular? That means that they are crossing at 90 degrees, as we see here. The way that you find the slope of your line when you know the slope of the line that's perpendicular is your line is going to be the negative reciprocal. What that means is you flip the slope over and take the negative of it. In this case, the original slope is the blue line, and it's, again, 2. That means that the red line is negative 1/2. Flip it over, change the sign. And we have a point, and the point is -2, -4. So in point-slope form, we would have y minus a -4 is equal to, now my slope is going to be -1/2 because it's the negative reciprocal of the previous one, which was 2. X minus a -2. Well, we don't want to leave it that way. We want to handle those negatives. So this becomes y plus 4 is equal to -1/2 times x plus 2. Now that's the point-slope form. What about slope-intercept? Well, remember we solved for y to get there. So this becomes y plus 4 is equal to -1/2 x. Well, what's half of 2? That's 1, but it's negative. So it would be -1. Now we want to move the 4, so we're going to subtract 4 from both sides. We have -1/2 x minus 1 minus 4, which is -1/2 x minus 5. So that becomes then your slope-intercept form, and up here is your point-slope form. Take a look at this one. In this case, they didn't give us a graph, but they gave us some similar information. It says, use the given conditions to write the equation of the line in point-slope form and slope-intercept form. Passing through a point, so there's our point, -2, -8, parallel to the line whose equation is y equals -4x plus 3. So we want to be parallel. That means we have the same slope. The slope of the line they gave us is -4. So we want to have the same slope, -4. So now we have all the information we need. Again, we're going to start with y minus y1 equals mx minus x1. That's the form for point-slope. Using the point they gave us then, it would be y minus a -8 is equal to, well, let's see, the slope is the same as the other line because they're parallel, so this would be -4 times x minus a -2. But we want to change those negatives because they're double negatives are positives, so this would be y plus 8 is equal to -4x plus 2. Now we have the point-slope form. We want to solve that So first of all, let's do the distribution. Minus 4x minus 4 times 2 is minus 8. Now we need to subtract 8 from both sides. So that would be y equals minus 4x minus 16. And again, that would be the slope-intercept, and this is the point-slope form. Another problem with given conditions. It's passing through the point 2, comma, negative 6, and it's perpendicular to the line whose equation is y equals 1/5 x plus 1. Well, let's see. We know the point. We're perpendicular to a slope of 1/5. Remember, we flip it over and change the sign. Well, if we flip 1/5 over, we'd have 5 over 1, which is 5. It's positive, so we change the sign of negative, so it'll be negative 5. So our slope is negative 5. So, in point slope form, we're going to have y minus y1 is a negative 6 is equal to, we determined Rm is negative 5 times x minus, and x1 is 2. Well, let's see, we can clean this left side up. That's y plus 6 is negative 5 times x minus 2. So there's your point slope form. Now let's solve for y. Well, y plus 6 then is equal to negative 5x. Negative 5 times a negative 2 is plus 10. Two negatives make positive. Now we need to subtract 6. So y is minus 5x plus 10 minus 6, or y is minus 5x plus 4. So here is your slope-intercept, and here is your point slope. Now let's look at a situation that uses this type of information. And let's see if we can figure out what the graph is going to look like. In the year 2000, 48% of the residents in a large city regularly use newspapers for getting news. And this has decreased at an average rate of approximately 1.3% per year since then. Find a linear function in slope-intercept form that models this description. The function should model a percentage of residents P of x. So P of x is our function. Remember that our function is always measured in the y direction. Who regularly use the news outlet X years after 2000. So if we're looking at X years after 2000, 2000 is our starting year, and that's 0. So 2001 is 1, 2002 is 2, and so forth. What that says then is that 48%, which happened in 2000, happened at the year 2, the 0 year, which is our y-axis. And therefore, 48 is our y-intercept. We're decreasing at a rate of 1.3% per year. Notice that when you see things per something else, oftentimes you see it as a fraction. If you see miles per hour, a lot of times that'll be the miles on top with the hours on the bottom. That's how you figure miles per hour. So that's our slope. It's 1.3 over 1, or 1.3. But it's decreasing, so it's going downhill. That means it's minus 1.3. Another way of saying that is, in the year 2001, 1 year after we started, we'd have 48% minus 1.3% that year. So we'd be down to 46.7% readership after the year 2001. Okay. So let's take a look at it. We said we have a slope, so P of x, we said is negative 1.3. We're going to leave it in percent form. I know that a lot of you are used to changing it to decimal, but it said that we're going to talk about it in percentages. So the graph is going to be in percentage. It's going to be starting with the number 48. And we're going to say the y-intercept is 48. So there's our equation. P of x is equal to minus 1.3x, it's the slope, or rate of change, plus 48, that's the starting point, or the y-axis. So that's our answer. So I hope that you now have a feel for working with equations with slope and points and applying them in a real-life situation.